Hi everyone, my name is Aakarsh Anugu,
I'm Anthony Maranto.
I'm Anirudh, Umarji.
I'm Raghul.
and we've created the CometMart database design. So our CometMart is mostly a general store that has all kinds of, entities or categories like customers, products, purchase, sale clerks, cashiers, and managers. And the customers will have a single cashier who will, take care of their supplies, and they will purchase a number of products that make up their order. In addition, each cashier will be assigned a manager who will oversee all their duties or issues that deal with the customer. And the suppliers will make sure that the store gets all the products on time and there's no delays. And okay, so for the entity, it's named employee that keeps track of all our employees. And its subtypes or supertypes and subtypes are the managers and sales clerk / cashier.
So we invented several business rules that we believe are significant for running CometMart. One, a customer can only be served by one sales clerk. Customer entities you see are per visit. So every time a customer, even if they've come to CometMart before, enters the store, we'll create a new customer entity to track their data. One sales clerk may serve many customers, seems fairly self-explanatory. One customer may purchase many products. One product may be purchased by many customers. One manager may oversee many sales clerks, and each sales clerk may only be overseen by one manager. One manager can solve problems with many customers. Likewise, one customer may have problems solved only by one manager, actually. Again, because customer entities are per visit. One supplier can supply many products, but a supplier can be supplied. A product can actually also be supplied by many suppliers. So those are our primary business rules for running CometMart.
The entities we used were customer, supplier, product, employee, and then we have two sub categories in employee, which is cashier and manager, and then we have purchased item.
So, for the EER diagram, the first relationship that can be seen is between supplier and product. One supplier can sell many products, and one product is just sold by one supplier. There's a many-to-many relationship between product and customer, so we created a bridge entity named purchased item. So one product can be sold many times, and one customer can purchase many products. There is a many to one relationship between customer and employees, and there is also a recursive relationship inside employee where an employee can also be a manager and can manage different employees. There's a cashier entity in which a customer is billed by one customer can be billed by only one cashier, and one cashier can bill many customers. And the last relationship is between employee and cashier, and one employee is a cashier, so it's a one-to-one relationship. Each entity has many different attributes inside it, which consists of primary keys and foreign keys. Okay, so the first entity that I will be talking about is supplier. Supplier helps in supplying all the stuff to the customers and to the CometMart. So the supplier has detailed information about products, and a supplier may sell many products. It has a supplier ID, which is the primary key, a supplier name, and supplier city, which are the attributes. The relationship, so one supplier can sell many products. Each product inside CometMart, they take it from one supplier. So apples can only be purchased from a particular supplier. So that is the relationship. And for the DDL, we had a schema named Simple Company 2, where we created a table named Supplier, and we put supplier ID as the primary key, and supplier name and supplier city.
Entity is a product, and for each product, is provided by one supplier, and the variables for the product are the product ID, product name, the price, the supplier, the brand, and the quantity. And the relationships for the product would be one-to-many. That's between the supplier and the product, because you can sell many products, I guess, for one supplier, or they make many products. And for the other one, it would be one-to-many as well, especially for the purchased item, because you can purchase as many products as you want. And for our table, we created a schema called Simple Company 2 with the table called Product. And our product ID is the primary key, along with I guess the strings, product name, brand, and you got an int for quantity, same, and a double for price, and an int for supplier. And your supplier is the foreign key.
So purchased item is something we created specifically in phase 2. It's sort of a bridge entity between product and customer, which enables the many-to-many relationship between those two. It essentially represents a single instance of product with a certain quantity that has been purchased by a customer during one of their visits. Like I said here, it defines the many-to-many relationship between those two items, and it just has 3 columns: product ID, a foreign key to product; customer ID, a foreign key to customer; and the quantity that was purchased during their purchase. This, of course, means that you should only have one instance of these with any one product ID and customer ID. So like I mentioned, the relationships in purchased item, it's a bridge entity. Essentially, the sold relationship describes the relationship between product and purchased item, saying this product was sold to this customer and purchased. Likewise, this purchased item was purchased by this customer. So the DDL is relatively simple. Once again, we created in our simple company table. Primary key is both product ID and customer ID. Because again, this entity can't exist without these foreign key references. We define product ID, customer ID, quantity. None of them can be null. All of them are integers, just because of logically you can't split up products when selling them, and obviously these two are integer keys.
For the customer entity, so for any new customer instance is generated every time a person visits the store, even though it's not their first visit. So the variables would be the customer ID, which is the primary key, then the first name, last name, their phone number, their address, and the cashier that serves them, and the employee. The relationship for the customer, first for the purchase bridge, would be many-to-one, since the relationship between the purchased item and the customer is defined by the purchased item, the customer ID. And for the bills, it would be one-to-many, since it's a relationship between the cashier and the customer, defined by the customer served by. And the dispute managed would be one-to-many, since the relationship between the employee and the customer is defined by the employee's dispute managed by, which is a nullable 4 key. And in addition, this describes a customer as a dispute that is managed by an employee during their visit. And this is our data definition language for customer, and obviously the schema simple company 2 with the customer table, with customer ID as our primary key, with first name, last name, phone number, address, and served by and dispute managed by.
The next entity is cashier. Cashier is a subtype of employee. Cashier is an employee who sells products to the customers. Because it is a subtype, the primary key is employee ID, and it also has another attribute, which is product sold. The relationship that cashier has is with bills. It has a one-to-many relationship with customers, because a customer bills many cashiers. It has a one-to-one relationship with employee because a cashier is an employee, so it's a subtype. There is a note that the relationship may not be present for every employee because every employee is not a cashier. Some employee are managers, some employee are cashiers, and some employee are not either of them. For the DDL, we still use the simple company to schema and created a table named cashier. We set employee ID as the primary key because it is a subtype, and products sold as another attribute. The foreign key is employee ID because it references the employee ID from the employee table.
Employee consists of employee ID, which is the primary key, first name, last name, SSN, salary, and manager ID, which is a foreign key to the employee table. In the employee table are dispute managed and is the cashier. The dispute managed is a one-to-many relationship. The relationship between the employee and customer is defined by employee's dispute managed, which is a foreign key to the employee's employee ID. This also describes that when a customer has dispute that is managed by the employee during their visit. The is a cashier relationship between the employee and a cashier is defined by the cashier's employee ID, which is a foreign key to the employee's employee ID. In the cashier TDL, we have used employee ID, first name, last name, SSN, salary, and manager ID as attributes. The primary key is the employee ID. The unique index we used is employee ID unique, and the index we used is manager ID X. The constraint is manager. The foreign key is manager ID. The preferences we used are simple company 2, an employee.
So this is essentially just the MySQL generated ER diagram. It's not quite as good as our other ER diagram, but it does list all of the types on it, which is useful. So we thought it would be good to include it, especially since now we are going to be transitioning to showing our database in action in MySQL Workbench.
Now we will explain the DML statements that we use to populate the database. DML is data manipulation language and is used to make manipulations to the database, usually in the form of inserting data, deleting data, or updating data. So the first table that we updated is the supplier table. As you can clearly see that we have data in the supplier table that we have added using the insert statements. The next table that we can see is purchased item, where we also use insert statements to add data to. And similarly, we added data to all the different tables like product, employee, customer, and cashier using different SQL insert statements. It is also seen that the primary key foreign key relationship is maintained between supplier and product, where you can clearly see that the supplier 1 supplies certain things to supplies certain products to the CometMart. In the future, we can also use delete statements and update statements to make changes to the same database as CometMart keeps growing. Thank you.